All right, so to start chapter 4, this is a continuation of unit 2. Unit 2 is technically chapters 3 and 4 in your textbook. And so if you want to follow along there, where'd my textbook go? Okay, right here. So chapter 4 in environmental science, McGraw-Hill Ryerson textbook. So this is going to start on about page, what? Let's see. Anybody on the, got that open in front of you? 90 maybe? Yeah, page 90, right on. Okay, so page 90, energy use for a sustainable future. All right. Let's launch right into section 4.1 on page 92. All right, global climate change. You've all heard of climate change, right? You've all heard of that. You know what that is. Well, let's talk about it some. It's a long-term change in the Earth's climate. These effects being felt today are the main driver for sustainable use of energy resources around the globe. Okay? So climate change is the main reason why there is such a push for these. And again, it is generally accepted. Okay? Not everybody is 100% believing everything that you hear about climate change. Some believe our destruction is literally imminent. Like the world's going to be destroyed within years. And some people are like, wow, this has happened before. I think we should just take a breath here before we, go too far with trying to address this. So there's people are on a different continuum, a different scale of alert, right, for this. But certainly we can look at what's been happening over the last 100 years with the Industrial Revolution and different things that we are doing in our on the planet, and we can see some clear connections with some of the changes that we're seeing. So for wherever you are on that sort of scale, okay, of 1, it's no big deal, it may or may not even be happening, and 2, this is really, really bad from what I understand the history of the universe has been, that we need to do something now or else we're all going to die. Wherever you are on that scale, there are things that we can be addressing to even just be better stewards of the resources that we have, right? Just to live cleaner, to live better in the world, and not to use so much stuff for possibly such little reason, okay? So it's a great idea for us to be better stewards of what we've been given, and I would like to frame it that way. And so looking at alternative energies and what we consume and what we take from the earth and how we manage our waste and different things, that's very important for us to consider no matter where we are in the whole climate change spectrum. Okay? Can I just start by saying that? It's good for us to explore cleaner, more efficient ways of doing things. All right, the graphic on page 92 of your textbook looks something similar to this. This is not from the textbook. This is I think a free image I got on the internet. But anyway, this shows how climate change affects This shows how climate change effects result from a warming climate. So you can see that these glaciers, these bits of ice, that they're starting to melt. Okay, and of course in your textbook on page 93, there's a picture taken in 2002 of a glacier that's largely a big chunk of ice, and then in 2007 it's largely a lake. It's just melted. So there's definitely changes happening in the world, right? Warmer climate temperatures cause land and sea ice to melt, which in turn causes an increase in sea level. This increase could cause more coastal flooding. And so one of the effects of a warmer climate generally is we have more ice in the world melting, and when ice melts, it makes water, right? Ice is water. When ice melts, it doesn't make water. When ice melts, it turns back into water, and so we have higher levels of all sorts of things. And on a large scale, that even a small increase in the water levels around the oceans could cause coastal flooding to be pretty bad. As the temperature of seawater increases, it becomes also more acidic. So there are different gases that can be dissolved into water that aren't able to be dissolved when it's cold. And so those gases that are able to be dissolved into water in warmer temperatures often make the pH or the acidity change. You guys have a question? Or okay, please pay attention. Okay, so differing temperatures also changes the acidity of waters, which is felt keenly by things like coral reefs and other ecosystems in the oceans. Yeah. Oxygen also, like, if you have a warmer water, not as much oxygen will be able to be dissolved in there, so it's harmful for fish and things too. So, okay, a warmer climate also increases frequency of extreme weather events. These weather events, such as hurricanes, floods, and tornadoes, threaten human life across the globe. So, in 2024, where we are right now, the coast of the U.S. coast is experiencing their second hurricane coming through within like weeks. So there's lots of stuff going on. Yeah. So I mean, there's all sorts of factors, but yeah, this is a bad. North Carolina got hit really, really bad. Now Florida, from the Gulf Coast, is going to be hit by another hurricane. And I mean, it's been a long time since I've, remember this happening, but like they haven't even cleaned up from the first hurricane, and so we have all this debris that could really, make things even worse with a second storm coming through. That's the debris that's kind of available to get thrown around, right? So yeah, it's a pretty desperate situation, for sure. And this is happening seemingly a little more often than it used to. Technology such as satellites and computers is often helpful. The technology is often helpful in determining the effects of climate change. Models based on current and past data can generate predictive climate situations. Now, these are not without their flaws, but can give us a good idea of what might come given our current practices. So the models, there is a certain bit of error along with the models. Okay, obviously not everything comes to pass that is predicted, but the models are fairly accurate in predicting what the most likely situation is. And so when we're talking about weather events, even like storm trackers and stuff like that, like, yeah, they see what's happened with the storm and they're predicting where the hurricane's going to make landfall. Have you heard that phrase, landfall? Yeah. Making landfall is when the hurricane actually starts to, come over land. So it's obviously there's storms in the sea all the time, but it's not really affecting us because we don't live on the ocean. But when it makes its way to the land, then there's a lot of damage and a lot of rain. In the North Carolina storms just recently, I was hearing stories, like I've heard lots of stories and friends of friends who have died in that, like there've been landslides and stuff like that, like literally like half a mountain just kind of like, it gets so saturated with water it just like comes away and like buries houses and towns and stuff. And this hurricane has brought so much water, so much rain, that there's one place that got 24 inches of rain, 2 feet of rain. Like if we get 2 inches of rain, that is a ton. So 24 inches of rain is like crazy, right? That's what they do. Okay, so I have this here, and I think this would be, let's see, copy link. Okay, let's see if that's going to be good enough. Did I get everything there? Okay, I'm going to look this up for you. Okay, so let's see if this is going to come up here. Okay, enable map scroll. Okay, we should start to see something. Yeah, look at this. Okay, so this is National Environment Satellite Data and Information Service. So look at this right here now. So this is the hurricane that they're talking about. There's another one in the ocean here right now that is heading away. Oh, here we go. We got some more images. So can I zoom in somehow? So this is Hurricane Milton here. It looks like this is kind of where it is mostly kind of right now. So it looks like it's already passed through Florida. Yeah, but this is sort of the what it looks like. I looked up the one the other day with Hurricane, what was it, Helene? That was, and it was like it was kind of here and then kind of went up here. The Yeah, the Carolinas and that, and so it really busted up this coast over here. So yeah, so if you want to, this link will be on the website. So if you guys want to check into this, and yeah, take a look at it. But this is the hurricane that we've been just talking about in the news. Okay, the greenhouse effect is a process that absorbs outgoing infrared radiation in the Earth's atmosphere. Is that what's next then for you guys there? Right? Yeah, after that one? Okay. So we talked a little bit about this, but as heat comes in from the sun, it's reflected off of the surface and heats up the air in the atmosphere, right? And so if not enough of that heat is able to dissipate, then we have generally a warmer situation. Greenhouse gases in the atmosphere absorb this radiation and hold heat. Shh, guys, don't talk while I'm talking, please. Zip it. Greenhouse gases in the atmosphere absorb this radiation and hold heat. These gases are necessary for our atmosphere to retain heat for us to live. So this is actually a good thing that we have these gases in our atmosphere. This is very helpful for us. But the imbalance of these gases is causing our climate to warm too much. Our current global average temperature is above 15 degrees Celsius. Without the greenhouse effect, the average global temperature would be negative 18. So without these gases and without this effect, and when you think of greenhouse gases and greenhouse effect, it's not always a bad thing. It's bad because it's working too well, I guess. It's retaining too much heat, and these are from gases that we are putting into our atmosphere, which is making this difficult. But without those gases, we wouldn't be able to hold the heat that's necessary. So it would be quite a change. Okay. Any questions there? All right, page 96. If you got your textbooks open there, you should be kind of flipping through a little bit. Page 95 is the greenhouse effect diagram here. Page 96. And table 4.1 shows principal greenhouse gases and human-generated sources of these gases. So on page 96, part of your homework is to memorize these 4 main greenhouse gases. So listed in the textbook here, we have this chart is just from the nets, not from your textbook. But we have carbon dioxide, which is one of the most common ones that you hear about all the time. Methane, chlorofluorocarbons. Okay, chloro comes from, how many of you are in, anybody in chemistry right now or physical science? Physical science? Okay, so chloro is the chlorine, Cl, number 17 there. Fluoro is from fluorine, number 9 on the periodic table. And carbons, from carbon-based. And the 4th one is nitrous oxide. Okay, so also on this table, you'll see sort of what the concentration is, pre-1750, what the concentration was in 2010, how each of these types of gases contribute to global warming, and what the principal sources are. So that table 4.1 is very important for you guys to study. Okay, so you should memorize these 4 categories and study kind of the rest of that table. Chris?
What is the chemical formula for chloride, fluor?
No, this is just a category of compounds.
Compounds?
It's a category of compounds. Yeah. A sustainable energy system is one in which the perception, production, and use of energy ensures that energy is sustainable. This system has the following characteristics. So we've talked about sustainable energy, and a sustainable energy system has the following characteristics. Number 1, the extraction, so that is taking out of, the extraction, production, and use of energy have limited impact on environment and human health. So taking what we need out of the earth, or extracting it from its original source, producing it, changing it into what is usable, and the actual use of the energy, if they can have the least amount of impact on the environment and our human health, that would be a sign of a strong, one characteristic of a strong sustainable system. Number two, there is less reliance on non-renewable resources. So I don't think we'll ever get away with not using some non-renewable resources, because there's kind of one-time use things that kind of are all over the place. But a less reliance on them would be a hallmark of sustainable system. Number three, the sustainable system ensures availability of renewable and reliable energy resources for current and future generations. So being that these are available, it's important too, and provides access to affordable energy for the entire global population. So also the cost, and cost of new technologies are often really high, right? So if we can bring those costs down by maybe making them more abundant or just being more efficient, that's also going to be really important. So these 4 points, make sure you study these 4 points. You should do your very best to memorize these as well. So you should plan for the tests and quizzes, assignments, especially the test. You should plan for some fill in the blanks, some multiple choice. So these are notes you need to study. Okay, so yeah, page 99 is 4.1 summary, and there'll be some questions there that I'll ask you to do in a bit. On page 100 is where section 4.2 starts. There is a figure 4.7 on this page, shows the pyramid of sustainable use of energy. So here it is. I've got one that's similar to the one in the textbook right here, but you can look on page 100 for yourself for right now. The lower level shows that every person can conserve energy by altering certain habits, such as turning off lights, using less water, closing the blinds on a hot summer day to keep your home cool. So here's the lower level right here. Everybody can conserve, energy conservation. And this is the first and most obvious way that we can contribute to using fewer resources. Conservation. The next stage, the middle section, refers to energy efficiency. So purchasing and using energy efficient light bulbs and appliances and securing proper insulation for your home can lead to sustainable energy use. So turning off the lights when you're not using them, and when you are using the lights, using light bulbs that are maybe a little more energy efficient, whether they're LEDs or CFL bulbs or whatever you might have. Using appliances that are Energy Star, right? Insulating your home. If you have an old house, probably the insulation is not that good. That happened to me when I bought my first house. The insulation was pretty poor, so I insulated the whole house, got new windows, blew insulation into the ceiling, and got a new, more efficient furnace, and like, boom, things changed very rapidly. I saved money, didn't have to use my furnace as much. In the summertime, wasn't cooking, it was, kept the heat out. My insulated home kept the heat out a bit better, and so on. And let's see, the top of the pyramid is renewable energy. So this takes money, research and development, and a willingness to change our current lifestyle to move towards renewable energy use. So renewable energy, as we've been studying, solar, wind, hydro, all that sort of stuff, is a way of finding alternate sources. So this is just being careful with the sources. This is using less energy with really the same sources, and this is different sources. So the large section on the bottom is what everybody can do, and there's large scale of this can make a change. And then, this is, the middle section is sort of what most people can do, or what, the application is just a little less wide. And then renewable energy would be, there's less of it, but it's just important too. It's really important up there. Okay, any questions about the pyramid? Conservation, efficiency, and renewable energy. All right, page 101, table 4.2 shows efficiencies of common household devices. So this is kind of interesting too. I do not have this chart on in your notes there, but on page 101, the most inefficient common household, that should be device, not advice. Device, that was a typo. Device is the incandescent light bulb. So this is like the old school traditional light bulb shape incandescent light bulb. It converts only 5% of its electrical energy to visible light. So when energy passes through this light bulb, all the energy that it takes, only 5% of that would be effectively converted into usable light. It's easy to make, it's cheap to make, but it's not very efficient. The most efficient household appliance might be an electric heater, which converts 100% of its electrical energy to thermal heat energy. Okay, now it's still, the heater might cost you more money than the light bulb, but it's more efficient. The actual components of the heater would heat up too, so you might not feel that. I mean, if you felt it, it would burn you. So you might not actually get the benefit from 100% of its energy going through it, but at least its energy is really mostly converted to heat. Okay, let's just pause there for a second. Let's look at that chart. So an internal combustion engine uses about 20% of its energy for force. So chemical energy from the gas bonds and the gas molecules to the movement or the mechanical energy of the car, about 20%. A microwave oven is about 65% of electrical energy converted to that thermal heat energy. An electric motor is very efficient. So the electricity to mechanical energy, electric motor is pretty efficient. And electric heater is right up there, is almost 100%. Okay, energy conservation includes choices and changes in behavior that enable people to use less energy without sacrificing the services that energy provide. So along with your textbook, again on page 104, there's a more comprehensive list of ideas on how to conserve energy. So I'll just read you a few of those bullet points. I don't think I have them listed here. So like we've been talking about, turn off the lights when you're not in use. Use natural lighting whenever possible, okay? Windows, pull your blinds apart, use natural light in rooms whenever you can instead of lights. Wash a full load of clothes using cold water. So if you can use cold or at least cool water, the colder the better. You're saving less energy using just natural cold water. And if you can wash a full load instead of just a little bit. I know you use less water for a smaller load, but it's more efficient when you use because you'll have to do fewer loads, right? So run the dishwasher only when it's full. So that's a good one. Wait till it's full before you turn it on. Take showers instead of baths and take shorter showers. Depending on how often you bathe, I suppose. Showers generally tend to be quicker and you use far less water. And if you're wondering how much water you use when you take your shower, do this. Put the plug in. Put the plug in, take your shower, be as quick as you can, and then when you turn off the shower, look down at the water in the tub. And that's how much water you've used for your shower. Now when you fill a tub, when you have a bath, usually you're filling the tub halfway full or whatever. That's a lot of water. You let the water run for quite a long time, right? So I would challenge you to do that, as long as you don't feel like it's too gross. It shouldn't be gross. But just plug the drain and then take your shower. And then when you're done, look at the water that you have left in the tub. That's exactly how much water that you used for your shower. And so that's probably a good perspective for us to have. So the shorter the showers, the less water you'll use. And if you have piping hot showers, if you can cool it off a little bit, you would also save a little bit of energy. But you know, there's the trade-off, right? What can you do? Close curtains in the summer during the day to reduce that heat energy from solar energy from coming in to heat up your house. Unplug appliances that use phantom power. So if you're not using something for an extended amount of time, unplug it, because there's sometimes a little inefficient trickle, right, of energy that's being used. And adjust your thermostat when the building is unoccupied. A lot of people have a programmable thermostat. Do you know if you have a programmable thermostat in your home? Like a digital one where there's a schedule and it like changes temperature up and down on its own? Does anybody know if you have one of those? Okay, you should look up. And I think in here I'm going to be prompting you to go around your house and to look at what kind of energy efficient things you have in your house. I think that's coming up in the notes, but that's one easy thing to ask about or to look on the wall. It's usually like in your living room or whatever, like there's a thermostat. If it's one that's not digital, if you have to like turn it up or dial it up or push it up or whatever, then that's a manual one and you have to manually put it up and manually put it down. We have a digital one, like a digital thermostat, and we have the program on it. And so you set the program, for example, when we go to bed, I drop the temperature. Just so, because we're sleeping, we're usually wrapped up in blankets, so we don't need the house to be as warm. So I always drop the temperature to save a little money overnight. Then I have it kick in just before I get up. And so like about 5:45 or something in the winter, my furnace kicks in. And then it warms it up so that when I get up at 6 or thereabouts, the house is warm for me. But it's not, it's not staying warm for hours before I get up. It's just when I get up. Right? This kind of thing. I set my coffee maker for when I get up. So I get down there, A, it's fresh coffee, B, it's not been sitting there heating for an hour. And you know what I mean? So I turn it off right away when I pour my coffee, turn it off. So little stuff like this you think about over time. And now that I'm paying for my electricity as a responsible adult, you guys are not paying for your electricity, I'm assuming. Most of you are not directly. So you start to think about this when you're responsible for paying stuff, about how much you eat, about how many lights on, the amount of water that you use, all this sort of stuff. You really start to think about it. So what I'm going to challenge you guys with in this class and coming up here in the next little while is to take a careful look at how you're using energy in your house, what kind of energy inefficiencies that you might see, and how you can, on that bottom level of the pyramid, how can you conserve a bit more? Because it's really good for us to think about this, honestly. It's good for us to think about it, and you feel good when you try and use a little bit less energy, when you are impacting the environment a little less. It actually feels good to be efficient and to be responsible. So anyway, so that's coming up right away here, and then I don't have my notes in front of me, but so we would back up a page in your textbook technically to page 103, where it talks about, and you guys know this, you guys know these words, I'm sure you've heard these all the time, but recycling is an important part of sustainability, and it's important to reduce the products that we use that are inefficient, to reuse products for multiple purposes, and finally to recycle those things that can be broken down and used for other purposes. So you guys have heard those three words, right? Probably since you were in elementary school, like reduce, reuse, recycle, right? So the 3 R's of recycling, I think it's pretty cool. Reduce, reuse, recycle, that is awesome. If you can remember that, that's totally great. And I see that many of you have refillable water bottles. You're not using one-time use plastic bottles. That's great. That kind of thing is a perfect start, right? You have a nice water bottle, you just keep refilling it. That's great, Okay, let me hear from you guys. What kind of ways do you reduce, reuse, or recycle generally around? Pick one thing. What do you guys do? Other than the water bottle example. So that would be my example. You have a water bottle that you reuse the water bottle. Yeah?
Any food scraps you give to our chickens.
Food scraps you give to your chickens. Nice. If you got chickens, that's a good thing to do. If you don't have chickens, what could we do with our food scraps? Anybody doing like a composting, or do you have the green bin? Everybody have the green bin in town here? Like you have to put your food in the green bin, so it's okay. Compost it. Okay, good. What else?
We cut the container of the juice or the milk.
Yeah.
For like a contain water to wash the cars.
Okay.
Our cars
Yeah.
in the basement.
Reuse. So you reuse milk cartons. Let's say you cut the top off, so you have like a little. Yeah, we use those in the garden, right? We have a rain collection barrel too, a couple of them, and so we have the same thing. The milk cartons, the plastic milk jugs. Cut the top off a little bit there and scoop it in and use that as your pitcher or whatever. Yeah, reuse that way. Perfect. Anybody else?
Oh, comment.
Yeah, one more.
We use like the brown bags that we get from our deliveries. We use them for like our trash bags.
Yes. Okay. Reusing bags you get from deliveries or from shops or restaurants. Reuse them for your trash bins and that kind of. Yes, very good. Yeah, we used to use the plastic bags from like Superstore and Walmart and stuff. They don't have plastic bags anymore, so we used to use those, reuse those for garbage and different things. Yeah. All right, we talked about this in earlier chapters, but EnerGuide is a labeling system created by the Canadian government. It provides comparative information about the energy consumption of major appliances. So Energy Star appliances, here's the Energy Star label, the blue one, meet or exceed strict energy efficiency criteria. For example, an Energy Star qualified natural gas furnace means that it is over 97% efficient. Okay? So here's examples of the EnerGuide sticker and Energy Star labels. So this will give you the EnerGuide. It will tell you sort of how much energy that it will use usually per year. Does anyone know what kWh?
Kilowatts per hour.
Kilowatts per hour.
It's kilowatt hours. It's kilowatt hours. So it's not kilowatts per hour per se, but it's kilowatt hours. So it's like how much energy, how many watts how many watt hours, how many hours of energy that it would kind of use. Yeah, it's similar to per hour, I guess, but it's kilowatt hours. It's not kilowatts per hour. Because this is not 554 kilowatts per hour. That's a lot of energy in 1 hour. This is total how much you would use in a year. Does that make sense? So it's the equivalent to, it's basically.
It will lead to joule. Like the watts times the time equals to joule.
Yeah. So it's a measure of energy that's used in a year. I don't know the types, things like that. Cubic feet of, there's different things that, there's different things on here, but mainly this one here. And look at the arrow, okay? You see this arrow here? So this would be super efficient over here for this type of appliance. This would be very inefficient. So they kind of give you this sliding scale. It's like, hey, this one is on the fairly efficient side. See? So that's kind of nice to see that down there. If you compare different like fridges or freezers or whatever this might be on, then you would say, hey, one's 554 down here, one is 589 up here. Oh, well, that's less efficient, right? Or it's gonna cost a little bit more to run for a year, that kind of thing. Furnaces, this is where I first kind of started looking at this. Furnaces and air conditioners and things like that, humidifiers and blah, blah, blah. If it has this Energy Star on it, it means it's fairly efficient. Yeah. In the old house I was telling you I was working on, had an old furnace, like super old furnace, like a furnace that should have been in a museum. And when we replaced it, I can't even remember what the efficiency rating, like it was just like low. It was like low. They wouldn't even give me a number. Like, what is this one? What do you think the efficiency? It was just low. So, yeah. But now they're pretty efficient. It's kind of nice.
Hello, high school. Today.
All right, R value is a measure of the effectiveness of insulation. I'm not sure if I have any blanks in this section or no.
No.
Probably should have. The higher the R value, I guess this was unedited. I'm not sure what I did here. The higher the R value, the greater its ability to withhold heat from passing through it. If your home is insulated well, very little heat will escape in the winter, and very little heat will invade your cool house in the summer. So don't think of insulation in your house like a warm coat. It's like, I don't want a warm coat in the summer. Ew. No, because a warm coat always traps in your body heat, right? So in the winter, you want a warm coat because that's very good insulation. It traps all your body heat. It doesn't let it escape so that you stay warm underneath your coat. If you have a warm coat around your house, heat will not pass through it. So in the wintertime, if you're heating your house, heat will not pass through those walls and escape. It'll keep your house warm. In the wintertime, if you are ejecting the heat from your house using an air conditioner or whatever means, then it will keep the heat from outside coming in. So a better insulated house does not always mean a warmer house. Okay? And that's what a lot of people think. Like, it's very well insulated, it's going to be hot in the summer. No, it's going to be way cooler in the summer because the heat from the outside is not going to get in as easily. So it's a barrier. And a high R value means it's able to withstand the invasion of heat or the escape of heat, the movement of heat through it. Okay, so here's your homework as I was talking about earlier. What energy saving devices does your home have? Some examples are, and I want you to, this is part of your homework, you have to do this, go home and look through your house. Okay? Do you have skylights to allow natural light into a room? Okay, that's like literally windows in your ceiling, right? That's a skylight. Do you have an Energy Star rated appliance? So look at your furnace, water heater, fridge, freezer, stove, microwave, that kind of thing. Do you have any Energy Star rated appliances? Do you have a programmable thermostat that we talked about? Do you have any motion sensing light switches? Ooh. Or motion lights in your basement or whatever, like anything like that. Does anyone know what an on-demand water heater is? Okay, so how most water heaters work is it's a huge container of water and gas is piped to that water heater, and there's a flame in there and it just heats that whole thing up, and you have all this hot water ready for when the hot water tap turns on. This hot water goes to your hot tap, okay? And then new water comes in, it's continually reheated, so this all stays warm. Well, there's a bit of inefficiency there because this big container of hot water can lose heat if it's not used, and it'll have to keep reheating it. They're insulated pretty well, so they're supposed to be efficient. But an on-demand water heater, and again, I know a little bit about this, not a whole lot, but it's basically this little thing on the wall. You have cold water coming in, and it instantly heats the water as it passes through this little thing, and then whatever leaves this little thing is like really hot. So it like zaps the water as it passes through and does not store large amounts of hot water. Okay? There's a bit of a difference in the approach. That's called an on-demand water heater. Technically more efficient because you don't have to heat this large volume of water in your basement. Okay? So, in the space provided, you're looking for things like this. Okay? In the space provided, make a list of all of the energy efficiencies you have in your home. Okay? So that's part of your homework.